Yeah, guys, what's up? So today we're just going to be taking the derivative of two functions multiplied together, right? So let's do some math. By the definition of derivatives, we know that this is equal to the limit of n as that goes to 0 of g of x plus n subtract multiplied by f of x plus n subtract g of x multiplied by f of x. Can you guys see that? Yeah, you can. Okay, so, and of course it's all divided by dx, which is just n. Okay, cool. So we have that out the way. Well, let's do something to this top part right here. Obviously, we don't want to change the equation, so we'll add f of x plus n multiplied by g of x. But like I said, since we don't want to change anything, we'll also subtract f of x plus n multiplied by g of x. This seems useless, but it gets quite useful as we go on. Okay, so let's do something. Let's group some terms together. We'll group these two. Okay, and we'll group these two. So let's put some brackets around these things, and these two are also going to be grouped, right? So we still have our limit, of course. We can't change that. And we have these two terms, right? So g of x plus n multiplied by f of x plus n subtract g of x multiplied by f of x plus n. I keep changing how it's written, but like this is the exact same. But originally I written it like how this would be first and that would be second. However, that doesn't matter. We'll change it up as we go. So we add it by our second fraction, or our second group of terms, right? Negative g of x multiplied by f of x plus f of x plus n multiplied by g of x. And that's divided by n, right? Okay, cool. We seem to be getting somewhere. Well, let's do something that's even cooler, and we'll factor out repeating terms, right? So we can see right here that this is repeating, f of x plus n, and right here we can see that g of x is repeating. Okay. So what we can do right here is we'll put our limit, of course, and we can multiply, right? We can take it out, I mean, f of x plus n, and then multiply that by what's going on here, g of x plus n, subtract g of x, and of course we can divide by n again. Okay, let's do the second part right now. Well, we can take out what's repeating, g of x, and hopefully the paper is straight again. Yeah, okay, g of x multiplied by f of x plus n subtract f of x. Okay, so right there I just changed it a little, but it's the exact same. So originally I wrote f of x, then I wrote f of x plus n. Okay, and the reason I switched it is because it'll seem more common to you guys later on, but that's the main reason I switched it. And also, remember why I wrote subtraction? Well, this is a negative g of x, right? Negative g of x is just negative 1 times g of x. So we can take out the g of x and just multiply f of x by negative 1, right? So let's go on. Okay, we're actually done. This is our end result. This is what we have. Now, it may seem common to you guys. Look at what this is. Well, look at these parts actually. What do you see? Well, you see that this is the derivative d over dx of g of x, and this is the derivative d over dx of f of x. Okay, cool. Well, what now? Well, we still have our limit, but this is the last time we're going to introduce this limit because it's getting kind of old. Of f of x plus n multiplied by, what we establish is our derivative plus g of x multiplied by what, again, we established was our derivative in respect to x of f of x, and here in respect to x of g of x, right? Okay, this is the only term that has an n. So if we solve this, we can take out the n, and as you can see, as n reaches 0, this just becomes f of x. So we can just write it as that, right? Because of course we're approximating, but when they become infinitely small, it adds 0 difference to our equation. So we don't need any limits anymore. Now all we have is f of x multiplied by derivative of g of x plus g of x multiplied by the derivative of f of x. Interesting. Okay, and you'll see that no matter how many terms you add, you can keep doing this over and over again. So since this video is kind of short, actually 6 minutes is quite longer than I thought it would be. I thought it would be 2, but like if we have d over dx, and we're gonna just do it with the pencil. I didn't mean it to sound like that, but we're gonna write with the pencil of f of x multiplied by g of x multiplied by z of x. Okay. Okay, so first we'll group these, right? So we're gonna have f of x multiplied by derivative of g of x multiplied by z of x plus g of x multiplied by z of x. This is so confusing looking. This is a multiplying sign multiplied by derivative. Now this part is just some more information. Of course you can just stop watching right now, and honestly I think you should, because this could seem confusing to you if you're new to this. Actually it wouldn't be confusing to you if I was a better teacher, but since I'm just gonna go past this kind of fast, and since I'm a horrible teacher, this might seem confusing to you. Okay, so we have this part. Interesting. So we now have f of x multiplied by g of x multiplied by derivative of z of x plus z of x multiplied by derivative of g of x. Okay. Plus g of x multiplied by z of x multiplied by derivative of f of x. Okay, cool. Multiply f of x out, and we get f of x multiplied by g of x multiplied by derivative of z of x plus z of x multiplied by f of x multiplied by derivative of g of x plus g of x multiplied by z of x multiplied by derivative of f of x. Okay, and there you go. We're finished, right? So as you can see, it works for more terms than just more variables, I don't know, more functions than just 2. Okay, yeah, okay, I hope you guys enjoyed the video. If you did, leave a like, and see ya.